It's about time to get ready for the Coulomb's Law quiz. This quiz unlocks the Ohm's Law quiz, which is easier than the Coulomb's Law quiz. And you might be thinking, why would he do that? Well, my goal for this quiz, or my two goals for this quiz, I wanted to have a scientific notation refresher, and I wanted you to be able to describe or understand the relationships in this equation. So basically I want you to be able to use scientific notation to solve this equation and understand what's going on if we change some of these numbers. Things that are not my goals for this quiz, I don't care for this video or for this quiz about the finer points of inverse square equations, which this is because it's got this on the bottom. I'm not too worried about that. And I'm not interested in manipulating the equation to solve for the other variables. So like on this quiz, I'm not going to say, get one of the charges by itself or solve for the distance. I am not going to do that on this quiz. So let me get started with what I want to cover. So K in this equation is a constant. And basically this constant makes the math work. When you plug in the right constant, then when you solve the equation, you get the right force for Coulomb's law. And since this is a force, the unit here is going to be newtons. And so when you're taking this quiz, you're going to have to use N for the force, for newtons. Okay, so what else is in the equation? Oh, what's the constant? The constant is 9 times 10 to the 9th. Or if you like to write it like this. So you're always going to use that value for K every time. All right, what are these two Q's? These two Q's, these are the two charged objects that we're looking at. So charged objects. If you're going to measure a force of electricity between two objects, you've got to have two charged objects, and that's what these two Q's are. These are measured in, you guessed it, coulombs, or a capital C on the quiz. Okay? And then lastly, down on the bottom here, we have how far apart they are, or the distance. And that's going to be measured in meters. Quite often, when science type people use this equation, they're talking about like electrons orbiting the nucleus of an atom, and so you might see R here instead of D because we're talking about a radius. Either way, it's still just a distance. So whether you see D or R doesn't really matter to us. So just to take a look at this equation, let's plug in ones for everything. And we could keep the constant in here or we could ignore it, but I'm going to leave it in. So 1, and let's say this charged object has a value of 1, and let's say this charged object has a value of 1, and then let's say the distance is 1. So if we solve this, if we just put in ones, we've got 1 times 1 times 1 divided by 1 squared, don't forget to square it, we get 1, and we get an answer of 1. No biggie there. But what if I change one of these charged objects? What if I double it? What if I put a 2 here? Well, then what we have is we have 1 times 1 times 2 over 1 squared. So all we did was changed one of the charged objects. So 1 times 1 times 2 is 2, divided by 1 squared, we get 2. So basically, if we double one of the charged objects, then we double the force. Okay, that shouldn't seem like too big of a deal. And what if we fiddle with the distance? What if instead of a 1, we made this be a 2? So if we left all these three up here ones, what if we changed the distance to a 2? So we'd have 1 times 1 times 1. So we'd have 1 on top. And then 2, don't forget, it gets squared. So 2 squared is 4. So if we double the distance, if we move two charged objects twice as far apart, the charge on them goes from being a 1 to 1/4. So we say that the force was quartered. So you are going to have to do stuff like this on the quiz. Okay? Lastly, I'm just going to plug in some numbers for these 4 things right here, and I'm going to solve one on the calculator, and that will be the end of this video. Okay, so I made up some numbers here. The K, the constant, is always going to be the same. These two charged objects, they would be in coulombs. This distance is in meters. Some of you might be asking, what is the unit for K, the constant? Well, remember, force is going to be in newtons. So if we want our answer to be in newtons, the constant is going to have to be in something that cancels out coulombs twice and meters twice because it's squared. So the unit of the 9 times 10 to the ninth is going to be what, newtons meters squared per coulomb squared. A little bit. I don't care if we worry about that as freshmen. But anyway, let's plug in these numbers into the calculator and solve it. So we can do that all at once. So what have we got here? We've got 9 times 10 to the ninth. So 9. Uh-oh, whoops. I'm sorry about that. 9 times 10 to the ninth times 4 times 10 to the negative sixth times 6 times 10 to the negative fifth divided by, and on the bottom I had 3.5 times 10 to the negative fourth, and don't forget to square this. Lots of kids get these wrong because they forget to square them. And that's it. You can do this all in one operation on your calculator, and then you hit enter, and there is your answer. That's a pretty big answer, and hey, sometimes numbers are big. So this describes how you can get through the Coulomb's law equation quiz.